Hello students, welcome back to the science class. In our last class, we have discussed some concepts of gravitation. In this class, we will discuss some more concepts about gravitation. Students, let us now discuss about thrust and pressure. Have you ever wondered why a camel can run in a desert easily? Why an army tank weighing more than 1,000 tons rests upon a continuous chain? Why a truck or a motor bus has much wider tires? Why cutting tools have sharp edges? In order to address these questions and understand the phenomena involved, it helps to introduce the concepts of the net force in a particular direction. So, this is called your thrust, and the force per unit area, that is called your pressure acting on the object concerned. Let us try to understand the meaning of thrust and pressure by considering the situations given in your book. So, situation 1, when we wish to fix a poster on a bulletin board as it is shown in your figure 10.3, to do this task, you will have to press drawing pins with your thumb. You apply a force on the surface area of the head of the pin. This force is directed perpendicularly to the surface area of the board. This force acts on a small area at the tip of the pin. Students, we can demonstrate this situation with an eraser and a pin. See, this is an eraser and this is the pin. If I need to insert the pin inside this eraser, I just cannot insert it in a lighter way. I need to apply some force on the head of the pin. Okay? So, when I apply, you can clearly see that when I apply force on the head of the pin starts going inside the eraser. Again we will see this. See, this is the tip of the pin, isn't it? It has a very small area. So, students, when I apply force on the head of the pin, the force is directed perpendicularly on the surface of the eraser, and the force is being applied at the touching point of the tip of the pin and the surface of the eraser, and the pin starts going inside the eraser gradually. Okay. So, let us discuss another situation. When we stand on loose sand, your feet go deep into the sand. Now, lie down on the sand. You will find that your body will not go that deep in the sand. In both cases, the force exerted on the sand is the weight of our body. So, students, after the discussion about the situations given in your book and the demonstration that I have given, you have learned that weight is the force acting vertically downwards. Here the force is acting perpendicularly to the surface of the sand. The force acting on an object perpendicular to the surface is called thrust. Okay? When you stand on loose sand, the force, that is the weight of your body, is acting on the area equal to the area of your feet. When you lie down, the same force acts on an area equal to the contact area of your whole body, which is larger than the area of your feet. Thus, the effects of forces of the same magnitude on different areas are different. In these cases, thrust is the same, but effects are different. Therefore, the effect of thrust depends on the area on which it acts. Okay. So, students, let me demonstrate something to you. Okay. As I have already demonstrated the effect of force on pin. See, while I apply force on the head, the pin goes inside smoothly because the whole force is now acting on the tip of the pin and the pin is acting perpendicularly on the surface of the eraser. Okay? So, let us now take a screw. See, it has a larger area of contact, isn't it? So, if I apply the same amount of force, see, I am applying the same amount of force, rather I have to apply more force to make the screw go inside. See, I am struggling, I am struggling, I am struggling, I am applying more and more force, still the screw is not going smoothly inside the eraser because now it has a larger area in contact with the eraser. So, when I apply more force, then only it will go inside the eraser. But in case of a pin, I need less amount of force. Okay. So, the larger the area of contact, larger force is required or thrust is required to make the work happen. Same thing happens in case of sand. When we stand on sand, okay, the weight of our body is acting perpendicularly on the surface of sand through our foot, which is having a smaller area of contact. So, our foot goes inside. But when we lie down, what happens? We have a greater area of contact with the surface of sand. Though our weight is constant and the thrust is acting perpendicularly, but now we have a larger area of contact with the surface of sand. That is why we do not go inside the sand, rather someone should push us. Go inside, go inside, go inside. More force is required to make ourselves dig into the sand. Hope you have understood. Students, the effect of thrust on sand is larger while standing than while lying. The thrust on unit area is called pressure. Thus, pressure is thrust divided by area or thrust per unit area. Substituting the SI unit of thrust and area, we get the SI unit of pressure as Newton per meter square. So, pressure is equal to thrust per unit area. Okay. So, thrust is nothing, one kind of force. So, SI unit of force is Newton. Okay, and that of area is meter square. So, what is the SI unit of pressure? It is Newton per meter square, or you can write Newton meter to the power minus 2. Okay. In honor of scientist Blaise Pascal, the SI unit of pressure is called Pascal and denoted by PA. Okay. So, what is the SI unit of pressure? That is Pascal, and it is nothing but Newton per meter square. Okay. So, students, let us consider a numerical example to understand the effects of thrust acting on different areas. So, students, let us discuss example 10.6. It says a block of wood is kept on a tabletop. The mass of wooden block is 5 kg and its dimensions are 40 centimeter into 20 centimeter into 10 centimeter. Find the pressure exerted by the wooden block on the tabletop if it is made to lie on the tabletop with its side of dimensions bit A 20 centimeter into 10 centimeter and B 40 centimeter into 20 centimeter. So, students, let us discuss the solution. Students, the mass of the wooden block is given as 5 kg. The dimensions 40 centimeter into 20 centimeter into 10 centimeter. Here the weight of the wooden block applies a thrust on the tabletop, that is thrust is equal to force, that means mass into acceleration due to gravity. F is equal to mg. Fine. So, mass is given as 5 kg and acceleration due to gravity, that is 9.8 meter per second square. Fine. So, it comes about 49 Newton. Okay. So, area of a side, that is length into breadth, area. Length into breadth, in the first case it is 20 centimeter and 10 centimeter. So, area is equal to 20 centimeter into 10 centimeter, that is 200 centimeter square. Fine. So, when we convert it into its SI unit, it will give us 0.02 meter square. Fine. So, what is pressure? Pressure is thrust per unit area. So, thrust is 49 Newton divided by 0.02 meter square. And when we calculate, it will give us the value 2450 Newton per meter square. When the block lies on the side of dimension 40 centimeter into 20 centimeter. Okay. The other side has dimension 40 centimeter into 20 centimeter. So, area is equal to 40 centimeter into 20 centimeter, that is 800 centimeter square or 0.08 meter square. Fine. So, in this case, pressure is equal to 49 Newton divided by 0.08 meter square, and when we calculate, it will give us a value, that is 612.5 Newton meter square. Fine. So, the pressure exerted by the side 20 centimeter into 10 centimeter is 2450 Newton per meter square, and by the side 40 centimeter into 20 centimeter is 612.5 Newton per meter square. Thus, the same force acting on a smaller area exerts a larger pressure and a smaller pressure on a larger area. This is the reason why a nail has a pointed tip, knives have sharp edges, and buildings have wide foundations. Okay? Hope you understand this. Students, let us now discuss pressure in fluids. All liquids and gases are fluids. A solid exerts pressure on a surface due to its weight. Similarly, fluids have weight and they also exert pressure. Similarly, fluids have weight and they also exert pressure on the base and walls of the container in which they are enclosed. Pressure exerted in any confined mass of fluid is transmitted undiminished in all directions. That means, it is equal in all directions and pressure is equal in each part of the surface of the container. Okay? Students, let us now discuss buoyancy. Have you ever had a swim in a pool and felt lighter? Have you ever drawn water from a well and felt that the bucket of water is heavier when it is out of the water? Have you ever wondered why a ship made of iron and steel does not sink in seawater, but whether the same amount of iron and steel in the form of a sheet would sink? These questions can be answered by taking buoyancy in consideration. Let us understand the meaning of buoyancy by doing an activity. Okay? Students, as the activity that is given in your book, it says, take an empty plastic bottle, Close the mouth of the bottle with an airtight stopper. Put it in a bucket filled with water. You see that the bottle floats. Push the bottle into the water. You feel an upward push. Try to push it further down. You will find it difficult to push deeper and deeper. This indicates that water exerts a force on the bottle in the upward direction. The upward force exerted by the water goes on increasing as the bottle is pushed deeper till it is completely immersed. Now, release the bottle. It bounces back to the surface. Does the force due to the gravitational attraction of the earth act on this bottle? If so, why doesn't the bottle stay immersed in water after it is released? How can you immerse the bottle in water? Students, let me demonstrate this activity in my way. So, I have taken a container which is 3/4 filled with water, and I have a small container that is tightened with its lid. Okay? So, let me try to push this bottle inside water. You can observe that when I push it, see, while pushing it down, the bottle goes downwards, but it has some movement because it is having some kind of force in the upward direction. I can feel it. You can do it by yourself in your house as well. Take a glass filled in water and take a small floating object, that is any kind of small bottle, and if you try to push it downwards into the water, you can feel the pressure or the force in the upward direction. Now look carefully. See, the bottle is moving like this. Why? It is having some kind of force in the upward direction. Yes, I am feeling it. You can also feel it when you try to push it downwards. Now let us observe what happens when I leave the bottle. See, the bottle comes to the surface of the water inside the container with a force. Let us do it again. Let me try it. Let us observe what happens. See, I am leaving the bottle. It comes to the surface of the water and it floats on the surface of the water. So, it is having some kind of force in the upward direction within the liquid, or in this case, it is from inside the water. Okay? So, students, the force due to the gravitational attraction of the earth acts on the bottle in the downward direction. So, the bottle is pulled downwards, but the water exerts an upward force on the bottle. Thus, the bottle is pushed upwards when we leave the bottle. We have learned that weight of an object is the force due to gravitational attraction of the earth. When the bottle is immersed, the upward force exerted by the water on the bottle is greater than its weight. Therefore, it rises up when released. To keep the bottle completely immersed, the upward force on the bottle due to water must be balanced. This can be achieved by an externally applied force acting downwards. This force must at least be equal to the difference between the upward force and the weight of the bottle, so that it can be completely immersed inside the water and stay at the bottom. The upward force exerted by the water on the bottle is known as upthrust or buoyant force. In fact, all objects experience a force of buoyancy when they are immersed in a fluid. The magnitude of this buoyant force depends on the density of the fluid. Okay? Hope you understand this concept. Students, let us now discuss why objects float or sink when placed on the surface of water. Let us do the activities given in your book to arrive at an answer for the question. Take a beaker filled with water. Take an iron nail and place it on the surface of water. Observe what happens. The nail sinks. The force due to the gravitational attraction of the earth on the iron nail pulls it downwards. There is an upthrust of water on the nail which pushes it upwards, but the downward force acting on the nail is greater than the upthrust of water on the nail. That's why it sinks and goes to the bottom of the container. Students, let me demonstrate this to you. As I have demonstrated it previously, let me put this bottle on the surface of water. What you observe? The bottle floats on the surface of water. Why is it so? Gravitational force is acting upon this bottle in the downward direction, but within the liquid there is a force upthrust or buoyant force which is pushing it upwards. In this case, it is greater. That is why the bottle is floating on the surface of water. Now, let us do it in a other way. Now, students, I have a screw in my hand. Now, let me try the same thing and let me put this screw on the surface of water. Observe with a full concentration. See what happened? The screw, it went inside the water and it stays at the bottom of the container. You can clearly see it is now at the bottom of the container. Why is it so? Because in this case, the gravitational force that is acting upon the body, or in this case the screw, is greater than the buoyant force which is acting in the upward direction. That's why the screw goes inside. Now it is completely immersed inside the water. Okay, hope you have understood this concept. Students, the other activity says, take a beaker filled with water, take a piece of cork and an iron nail of equal mass, place them on the surface of water. Observe what happens. The cork floats while the nail sinks. This happens because of the difference in their densities. The density of a substance is defined as the mass per unit volume. The density of cork is less than the density of water. This means that the upthrust of water on the cork is greater than the weight of the cork. So, it floats. As you can see in figure 10.5. The density of an iron nail is more than the density of water. This means that the upthrust of water on the iron nail is less than the weight of the nail. So, it sinks. Therefore, objects of density less than that of a liquid float on the liquid. The objects of density greater than that of a liquid sink in the liquid. So, we know about two concepts. One is buoyant force and the other is density. So, whenever density is less than, that is density of the object less than that of a liquid, then the object float on the liquid. The objects of density greater than that of a liquid sink in the liquid. So, in our case, when I demonstrated, the density of screw was greater than that of density of liquid. That's why it sinks. And the density of the bottle was lesser than that of the water inside the container. That's why it floats on the surface of water. Okay, hope you understood this concept. Let us now discuss some of the questions those are given in your book. Okay, students, why is it difficult to hold a school bag having a strap made of a thin and strong string? Let us discuss. Students, we know that pressure is equal to force per unit area. When the string of a school bag is thin, its area is small, and as such the pressure exerted on the shoulders of the hands supporting the bag is large. In this case, the force acting on the shoulders or the hand which support the bag is equal to the weight of the bag. In case the strap is broad, as is usually the case, the area on which the force or the weight of the bag acts is large and the pressure is reduced, as the weight of the bag is now distributed over a larger area. Okay, hope you have understood this. So let us now discuss the next question. The next question says, what do you mean by buoyancy? Let us discuss the solution. Students, whenever an object is immersed in a liquid, either partially or fully, an upward force is exerted on the object by the liquid. This upward force is called upthrust or buoyant force or force of buoyancy, and the property of the fluid due to which this upthrust is exerted on the object is called buoyancy. Okay? So, let us now discuss the next question. The next question says, why does an object float or sink when placed on the surface of water? Okay? Let us now discuss the solution for this. Students, when the object has density less than 1 gram per centimeter cube, that is the density of water, then it floats on the surface of water because it always displays more weight of water than its own weight. As the buoyant force is more than its own weight, therefore it floats. When the object has density more than 1 gram per centimeter cube, then it sinks in water because it always displays less weight of water than its own weight. As buoyant force is less than its own weight, therefore it sinks. Okay? Hope you have understood the solution of the questions. Students, with this we have come to the end of this session. In this session, we have discussed some of the concepts of gravitation. In our next class, we will discuss some more concepts about gravitation. Okay students, so keep practicing, keep revising and be safe and keep smiling. Thank you.